The next slide discusses a deposition of thin film aluminum oxide by polymer-assisted deposition from Burrell. PAD is a low-cost spin coating process for depositing high-quality metal oxide films. This particular experiment was done with the assistance of Dr. Hungmei Lo and graduate student Guing Lu Lin at New Mexico State University, Department of Chemical Engineering. The procedure involved taking two fused silica and two calcium fluoride optical windows, which are 12.5 millimeter by 3 millimeter thickness, coating them with a quarter wavelength of 780 nanometer or 195 nanometer thickness of aluminum oxide in order to minimize reflections at depal input pump and output laser wavelengths. In the coating process, a precursor solution prepared by adding 2 grams of aluminum nitrate hydrate to 3 grams of petroleum ether insoluble fraction, or PEIF, prepared by slowly adding 5 mL of 48% hydrofluoric acid to 10 grams of PEI in 40 mLs of water, milliliters of water, while maintaining the pH at 7 in 40 milliliters of water. The final concentration turned out to be 158 millimole. Coated onto the sample 5 times, 40 nanometers per single coating, and the annealing temperature was set at 550 degrees Celsius for 3 hours. All samples were weighed after coating with amorphous alumina. And in the case of the calcium fluoride, you can see the measurements there. And in the case of the fused silica laser glasses, you can see those two there. The next slide shows. In the next slide, we discuss polymer-assisted deposition by aluminum oxide results of XRD, or X-ray diffraction spectra. As you can see, there are 4 samples scanned at 3 degrees per minute using an X-ray diffractometer, or XRD, at New Mexico State University, Department of Chemical Engineering. The spectra is shown. All samples only have background peaks in the spectra, indicating that coatings are amorphous. The next slide shows results from UV-vis spectroscopy of the polymer-assisted deposited aluminum oxide onto the witness samples. Transmittance is about 70%, 80%, 90%, 90% respectively, from wavelength range 780 nanometer to 900 nanometer was observed with a quarter wavelength coating of the aluminum oxide. This really shows a very high quality coating due to the high transmittance in the UV vis using the deposition using the pad technique. The next slide shows polymer-assisted deposited aluminum oxide via scan electron microscope at New Mexico State University, Department of Chemical Engineering. And as you can see, all samples have a smooth surface at the center. However, about half to a millimeter from the edges, the samples are not well coated. However, polymer-assisted deposition is designed to produce high-quality coatings over a large surface area. So this is a very useful technique to cheaply and effectively coat optical windows.